Today I'm going to show you how easy it is to turn metal on a wood lathe. I need to build a couple of decorative nuts to lock the door handles in place, so I decided to go back in time and use a very low powered lathe and freehand the whole thing. Normally I would use a conventional metal lathe to rough out the shape of the piece and then just use hand tools to profile the curved shapes that I needed. But today I'm going to do the whole thing by hand, and I'm also using the smallest lathe that I own. So this really simulates what it would be like to be using an old treadle lathe, for example. So this, I believe, is one of the smallest wood turning lathes that you can buy. It's just a benchtop model. The bed's maybe a foot long. It has a 2.3 amp motor, and it has a little shoestring of a belt on it. So I feel very comfortable working around this lathe and doing what I'm doing today. And I really want to emphasize this because it's really important that if you decide that you want to start roughing out metal freehand, it's really important that you use a lathe that you can overpower. You have to understand that when you're starting out, it's really easy to get your tool bit caught under one of these corners. And when that happens, you don't want to be on a big lathe that's going to just rip the tool right out of your hand and send it flying somewhere. You want to be on a gutless little lathe that's just going to stop anytime there's an excessive amount of resistance. So these techniques are okay to use on a treadle lathe or a watchmaker's lathe or any kind of a low-powered lathe like that. They do not belong on any kind of a motorized lathe unless it has an extremely small motor like the one that I'm using here. I'm going to be turning the nut on a threaded arbor that fits into the headstock of my lathe. So this end of the bolt was turned down to a number 1 Morse taper. I'm also going to be supporting the front of the arbor with the tailstock. Sometimes the vibration from the roughing cuts will cause the arbor to work loose and fall out, so the tailstock will keep it from moving out of position. I'm going to be doing most of the work today with a conventional high-speed steel tool bit. This one's just jammed into a piece of electrical conduit for a handle. I had a couple of cutters that were just made out of spring steel, but they didn't seem to hold up that well. I don't know whether I missed the temper or whether they just couldn't take all the hammering that was going on from the roughing cuts. So I decided to go back to the high-speed steel tool bit. Now the cutting principles are the same as on a conventional lathe. The edge geometry of the tool bit is going to be the same, and the relationship to the work is going to be the same. The big difference here, of course, is that you don't have a tool holder that you can adjust to get that perfect relationship between the cutter and the work. You just have to kind of feel and figure out where that sweet spot is and try to follow it for as long as you can. Here I'm trying a carbide cutter just to see how it works. You can see how once you knock the corners off of that square bar, it starts turning pretty nice even though it's nowhere near round. I think part of that is because of the vice grips giving an extra counterbalance to the tool bit and providing that much more stability to the cutter. So I'm definitely going to need to build a tool holder that I can use for this kind of work. And there's an example of why you want to be working on a low-powered machine. My face is just inches away from the work here because I'm trying to see, so that would have knocked my teeth out if I wasn't able to control it. Also, the fine chips that fly off of the corners of these things really go everywhere. They just fly off at such a velocity that they start bouncing around, and they'll get around eyeglasses or safety glasses that aren't really tight fitting. So if you have a full face shield, I really recommend that you wear it. Here I'm trying a different profile of carbide cutter, and this one actually works really well because the narrow tip was really able to carve into the work very easily with very little resistance. I have to say that I'm really impressed with the results of this experiment. I've never turned anything like this totally by hand. I've done a lot of freehand turning, but it's basically just been spindle shapes, knobs, that kind of thing. I've never taken a square block and turned it into a round piece, and I honestly didn't know if I could do it or not. I really didn't think that you could get the control that you need to rough out a piece by simply holding a tool bit by hand. And once again, you can see how this is nowhere near round, but it's turning quite nicely. So even though this was a fun experiment, I have to say that I would never do this. I mean, I would take the 30 seconds that it would take at the grinder to knock off these corners, and that would save about 20 minutes of turning. So it's nice to know that you can do it and that, that capability is there, but, there are a lot more practical solutions to the problem. So getting to a cylinder as quickly as possible is really the key to this whole process. You have to remember that if you're treadling on a treadle lathe, 20 minutes is a big deal. Standing by a lathe that's motorized for 20 minutes isn't that much of a challenge, but anything that you can do to conserve your energy is really important when you're using a human-powered lathe. And also, once you've reached the cylinder stage, you can really start leaning into the cutter and taking off huge shavings that may even be as big as 1/1000th of an inch. And that gets pretty exciting when you've spent the last half hour watching these little specks of dust flying off of this piece. I'm not doing any real measuring for these pieces. I'm just holding the finished piece over the one that I'm working on. If they're close enough, that's great. They don't have to be identical. They just have to be similar. I'm just doing a little bit of file work to refine the shape a little bit more. I'm not going to do a lot of finishing with the file because these are going to get thrown back in the fire anyway to get the same patina as the rest of the piece. Hi, I'm Dennis and thanks for watching. If you liked this video, by all means give it a thumbs up. If you want to support this channel, you have a couple of options to do that. The first, of course, is to just subscribe. Secondly, if you have any suggestions or photographs of things you'd like to see on this channel, send them along and I'll do my best to turn them into a video. If you want to lend your financial support, you can do that in a couple of ways. First, if you're interested in making an ongoing contribution to this channel, just click the Patreon icon and it'll take you to my Patreon page and you can donate whatever amount you feel comfortable with. If you want to make a one-time contribution, just go to my channel homepage and click the donate button in the banner. So thank you for your support, and with your help I'll be doing this for some time to come. I'll see you next time.